I realized that there's a third rune. Well, actually, four runes altogether. There's a primary rune um, of the inner primary or the primary numbers that make up the whole cube. There's a secondary rune, which I first realized tonight. And there's the inner ghost number rune. Then there's a composite rune of all of them together. um, the primary rune. Well, this is all in sequential order. There's not no double numbers or triple numbers, but I'll get to those too. This is all just 1, 2, 3, 4, 5, 6 around all the 6 sides of the cube and wrapping around it in a sequential order. Although this is not the only sequential order, they would all end up appearing the same in different rotations. So this is a sequential order, and there's no double numbers. And but even in a sequential order, after the first primary numbers, there's bound to be places where they double up at. Like there's 7 here, 7 here. There's 8 here. Well, there's 8 here, 8 here, 6 here, 6 here, 9, 10, 11. And there's different rules you can apply, graphing rules or graph rules, I guess. I don't know too much about graph theory, but there's different rules that can be applied, whether you want them to add separately or to their nearest neighbor or not to their nearest neighbor, or there's just different rules you can apply to these graphs when they double up, when the numbers double up. It's, do they separate into separate pairs or triplets or whatever? So that goes for the secondary in a sequential order, and it will go for the first, and I'll get to it. It will go for the primary numbers. It depends on the numbers you put around them. It don't do it with this. This is just one sequential order because it's 1, 2, 3, 4, 5, 6 wrapped around it sequentially. And but even with the secondary numbers that I discovered tonight, they can double up. And the inner ghost numbers, well, they can triple up, but they can also double up too, I believe. But they can triple up, 27, 27, 27, 36, 36, 36. And there's different rules that can be applied. And I might be using 2 separate rules for the secondary and the inner ghost numbers rune. And here's the composite of all of them together. And I'm sure there's some sort of sense in it. It don't make any sort of solid object that I know of. But there might be some sort of a meaning to all this mess. These runes hold some sort of meaning to them. And this is just a 1, 2, 3, 4, 5, 6 sequential order. This is well, I shouldn't have gotten to this yet. This is a double-helix cube. And these are the primary, secondary, inner ghost number rune and composite rune. And they divide in 2, 1, 2, 3 going up, 1, 2, 3 going down. They wrap around like a double helix. And but then right here, this is just yet another choice. I could have all 3s going to, well, where does it start at? All 3s going to all 4s, and all 4s going to all 5s. But I decided to separate them up. 3, 4, 5, 3, 4, 5, 3, 4, 5, and 3, 4, or 3, 4, 5. Well, this 3, 4, 5 goes up this way, and this 3, 4, 5 goes on this way. and these 3, 4, 5s go opposite each other and turn around. So that's one rule that can be applied using the graph theory, I guess, of how to, where do they go to next when there's more than one number, non-sequential order. And here's the ghost number rune. These are all the different ways it could be applied, and that they could be a simpler way, or they could just all stay the same. Since they all are the same, they could just not go anywhere. That's another rule of graph theory rule that could be applied. This is its composite rune. Then so I decided to think, well, if I can separate them into 2, what if I separate them into 3? 1, 2, 1, 2, 1, 2 cube. This is 1, 2, 1, 2, and 1, 2. These are the primary runes, if you want to call it primary rune set. This is secondary rune, and they can be either sets, or it could be all this mess, apparent mess, but they start from the lowest number and end at the highest number. 1, 2, 3, or 2, 3, 4. But there's 1, 2, 3. There's 3 of each kind, or probably 4 numbers. 3 and 4 duplicate numbers. And here's the inner ghost number rune. So I'm just showing how complicated it is to investigate these because of all the graph rules that can be applied, the different graph rules, and they have to be logically applied to each level of rune, from primary to secondary to inner ghost number to composite rune, where they're all put around there. And these individual runes and their rules, whatever set rules that might be applied to these, if there is a set rule, I believe these spell out some sort of secret to these runes. All these runes are, again, when I say runes, I just mean the vectors that add up from the lowest number to the highest number. And that depends a lot on the graph theory rule that's applied. Is it a graph theory or a graphing theory or a graph or whatever system of connections? And this is the composite rune. So in my research on these, I'm just back to square one in my mind. But I have found that there's 4 different types of runes. There's a primary rune, the secondary rune, the inner ghost number rune, and the composite rune. And you can argue that I haven't done the outside. Well, the double-helix model, that brings the outside inside. Like there's 4 on this square, 5 on this square, and 3 on this square. And that's what it would appear like outside here. So really it's just compressing, and that's interesting fact to me, that it's compressing, it's taking the outside property and bringing it inside, where all numbers are alike on the squares. This only happens in a double helix model, I believe. I'm pretty sure I'm right. It only happens in a double helix cube, and but it takes the outer squares, outer cube, and gives that property to the inner cube, where the numbers are alike. So, but it'd probably be useful to study the outer cube runes, and I'll probably get to that in the future. I'll get to that if it goes anywhere. But so far, this is just a discussion on the different runes that are possible. And so far, I've discovered the primary runes, the secondary runes, the inner ghost number runes, and the composite, all of them together for 1, 2, 1, 2, 1, 2, and for a double helix cube. I believe they have something to